Okay, so good day everyone. So this is ENS161, Statics of Rigid Bodies, Module 3.1, Analysis of Structures. So this is a continuation of Analysis of Structures, which is yung frames. So the first structure that we have discussed sa previous module natin or yung Module 3 is yung truss, and ngayon naman is yung frames. So welcome. So for this lesson, we'll be dealing with the equilibrium of structures in which at least one of the members is a multi-force members. So multi-force members is where a member acted upon by three or more forces. So sa truss natin, the member ng truss so is a two-force member lang yung truss natin. So yun lang yung truss. But sa frame is multi-force siya. So multi-force. So could be three forces yung acted on a single member or four, so or depende sa problem, no. So but ito yung difference ng truss sa frames. So frame is a multi-force structure or multi-force yung mga member niya. So by the end of this module, you should be able to define what is a frame and also analyze frame structures. So let's review. Truss is connected by a pins. So connected by a pin, and the member is at its extremities, meaning pin to pin is yun lang yung length or yun lang yung isang member. And then each member is a straight, so straight siya, and two force member. So ganito yung truss natin. So AC is one member, AD is one member, CD is one member, CB is one member, and DB is one member, and lahat sila straight. So and then pag separate mo yung each member, they are subjected to two forces lang, either compression or tension on both ends. So sa frames naman, frames is designed to support loads and are usually stationary, fully constrained structures. And also, frames are structures containing multi-force members. So sa frames, there are members na more than three or more than yung forces na subjected sa member na yon. So these forces will generally not be directed along the members, not unlike dito sa force natin. So unlike sa truss, so each member, the forces is directed along the member. So hindi siya paganyan or paganon. So ganito lang talaga yung sa truss, on each member. So their direction is unknown, and they should be represented therefore by two unknown components, no. So for example, if may applied force na at an angle, so of course break down mo yung force na into its two components. So here's an example of a frame. So as you can see, it is still connected by pins, but each member is hindi siya straight. So hindi siya straight, and it is subjected to three or more than forces. For example, this member A, C, F, itong member na to. So if tatanggalin mo to siya, if i-break mo yung each member, so merong force dito sa A, merong force sa C, which is vertical and horizontal force kasi it is connected by a pin, and also dito din sa F, no. So ibig sabihin nun, yung member ACF is subjected to 5. So meron siyang 5 forces na present. So mamaya try natin na kumuha ng isang structure, and then tingnan natin yung mga forces involved, no, which is more than 3 or more. So, ito yung difference ng truss and yung frame, no? So, obvious naman. So, yung truss is straight yung members nila, yung frames is hindi straight yung members. And merong, sa truss naman, you can only apply loads on the connections, like dito sa P and C. So, dyan ka lang pwede mag-apply. But sa frame, you can apply at any location. So, could be lateral or kahit saan. So, for example, dito, hindi siya nag-apply sa C or sa B, F, or so, nag-apply siya dito sa A. So, ganyan yung difference ng frames. Okay, so how do you analyze a frame? So, as a first example of the analysis of frame, so we'll consider here the crane na consider natin sa previous na discussion dun sa truss. So basically, this structure is not a truss but it is a frame. So, and then ito yung magiging free body diagram na. So this free body diagram niya. So there is a reaction at A, which is AX and AY. And then the tension at cable GD and the force, the weight of the suspended na weight na W. So yan yung free body diagram niya. So this diagram can be used to determine the external forces acting on the frame. So using the free body diagram, so we can determine the reaction at A, that is AX and AY. Now, in order to determine yung mga internal forces holding the various parts of the frame together, so we must dismember the frame and draw the free body diagram of the each component. Ayan, so i-dismember natin yung free body diagram, yung frame. Ito yung magiging free body diagram ng mga each member. So, we have for this frame, meron tayong tatlong member. That is member AD. So, ito, AD. And member CF and member BE. Now, starting with the two-force member. So, that is yung BE natin. So, BE is a two-force member subjected by force FBE and FB. So, the sign here, so usually hindi na naglalagay ng sign. But for emphasis, nilagay dito yung sign kasi to emphasize na FBE and negative FBE will cancel out and they are in opposite sense, no? So, opposite sense sila. So, this is a two-force member. Ito tinatawag natin na two-force member. Now, since this is a frame structure, so meron tayong tinatawag na multi-force member. So, ito yung multi-force member. Meaning, hindi lang dalawa yung forces niya. So, tatlo and also iba-iba ng direction. So, merong pa-left, pa-right, pa-baba. So, ito yung multi-force member. Also, yung member AD is a multi-force member. Okay, so all these internal forces are yung mga direction na are arbitrarily assumed, no? So throughout the calculation, malalaman din natin kung mali yung assumption natin or tama yung assumption. That is by knowing na kung positive yung sagot, meaning tama yung assumption. Kung negative naman yung sagot, meaning mali yung assumption natin. So for members, for example, yung member BE natin, this could be tension or compression. No? So, depende sa magiging resulta ng calculation. So, that is for the member FPE. So, next, we are going to consider yung multi-force member. Okay. So, say for example, at connection B, here, dito sa B, So this is the connection between a multi-force member AD and two force member BE. And at sa C naman, yung connection na to is connection between two multi-force members. So that is CF and AD. Okay, so with reference to the Newton's third law, so the force exerted at B for member BE must be what must have the same magnitude with but opposite sense to the force exerted at B at member AD. So ito no, ito. So dapat opposite sila of course para mag-take effect yung Newton's third law of motion, yung action reaction. So that goes the same for member C and member E. Now sa multi-force member CF, sa C, we do not know, 'di ba yung sa ano natin, yung sa reactions, yung original na ano ng hinge or yung pin, yung original reaction niya is a inclined force F, ito yung R at an angle theta. So yan yung original na reaction pag may pin or hinge. But since hindi natin alam yung angle or yung direction ng force, inano natin, ginawa natin dalawang component. That is yung x component niya, yung ry component. So, the same siya dito sa C natin. So, imbis na ilagay natin is yung force na naka-incline at an angle, but since hindi natin alam yung force na yon, yung direction niya, so yung unknown yung magiging direction niya and yung sense niya. So, ginawa na lang natin ng x and y component. So, and then, inassume natin yung magiging direction niya. So, that is, for example, naka-tension siya, no? So, naka-tension siya. So, at C, meron tayong positive y and positive x. And sa C naman, or upward na cy, then sa right na cx, and sa C naman, at member CF is dapat opposite yung sense niya compare with reference sa C sa multi-force member AD. So, that's why pa-left and pa-right yung magiging value or yung magiging direction ng CX and CY for the Newton's third law of motion to take effect. So, yan yung magiging ano, no? So, again, yung sign dito, yung sign, ito is, ginamit lang natin to emphasize na opposite ng sense yung two forces. Like, for example, for member BE, itong FB and yung FB na ito. So, emphasize lang. But sa mga calculations natin is, hindi natin nilagay yung sign na negative, no? So, depende na sa magiging sagot or magiging answer ng equation natin. Okay, so now, the internal forces, so with the members na dismember na natin and meron ng mga na-identify na natin or na-assume na natin yung mga internal forces. So, these internal forces cannot be determined by considering the free body diagram of either of the two multi-force members. Choosing the free body diagram, for example, sa kung ano yung unahin mo na multi-force member, so we will write the equations, yung summation of moment, summation of forces, and then masosolve na natin yung mga unknowns natin. So, of course, pag nasolve na yung mga unknowns mo, so kailangan i-check mo din, no, kung tama yung naging sagot mo sa solution mo. Okay, so to summarize. Okay, so in solving problems involving frames containing one or more multi-force members, we should follow these steps. So 1, draw a free body diagram. So sa engineering, no, lahat ng problems na may kasaling structure to analyze, mauuna talaga yung free body diagram. So, dapat ma-master yung free body diagram kasi doon nagsisimula yung problem solving natin. So, there are teachers na kung walang free body diagram is mali yung sagot, mali na yung sagot mo. So, kailangan talaga mauuna yung free body diagram. Okay, so you'll draw the free body diagram of the entire frame, and of course, you use this diagram to determine the reaction D support. So, muna tayo yung free body diagram and then solve for the reactions. Next is, you dismember the frame and draw the free body diagram of each member. So, doon malalaman kung alin yung member na multi-force member. So, there could be one member na multi-force or also two members na multi-force. So, depende sa structure ng frame. Now, after dismembering, you will consider first the two force members. So, katulad nung previous natin na slide, merong sa frame structure na yon, merong isang member na two force member. So, doon ka mauna, no? So, if kasi mas madaling ma-solve yung unknown. Okay. So, next is you consider the multi-force members. So, a multi-force member connected to a two-force member, or a multi-force member connected to another multi-force member. So, depende sa connection nila, no? So, it could be the connection between multi-force and two-force member, or multi-force to multi-force members. And then the internal forces and the unsolved reactions kasi there are structures na, for example, dalawang hinge yung nakakabit. So, meaning meron kang 4 unknowns. So, hindi mo masosolve agad-agad yung reactions using free body diagram lang. So, it has to be dismembered para ma-solve mo yung ibang reaction niya. So, the internal forces and unsolved reactions may now be determined. So, you draw the free body diagram, so you simplify the solution and arbitrarily choose the direction of each of the unknown forces. So, ito no, mag-assume talaga tayo ng direction ng forces. But in the end of the solution, if negative, meaning maling assumption natin. So, ito yung opposite niya. So, if assumption natin is tension, so pag negative yung labas, meaning compression yung force na yan. So, madali wag lang malito, no? So, yun. So, ito yung mga steps. And lastly, to be more effective and efficient as you proceed through your solution, so you observe the following rules. So, if an equation involving only one unknown can be found, write that equation and solve for that unknown. So, yan no. So, kaya inuuna natin yung two force member kasi yun yung mas madali ma-identify yung mga unknown forces niya. So, so after that, you immediately replace the unknown where it appears on the free body diagram by the value of that you have found. So, pag mag-next step na kayo, ilalagay nyo na yung value nung force na yun. So, hindi na yung like FAB. So, pwede na maglagay ng yung magnitude ng force na yun. So, repeat this process by seeking equilibrium equations involving only one unknown until you have found all the internal forces and unknown reactions. So, kagaya sa pag-solve ng joints, so kaya pinipili natin muna yung mga joints where konti lang yung unknown na members kasi mas madali mo siyang ma-solve and ma-apply mo yung equilibrium equations. And B is, if an equation involving only one unknown cannot be found, you may have to solve a pair of simultaneous equations. Before doing so, check that you have shown the values of all the reactions that were obtained from the free body diagram on the entire frame. So, ibig sabihin nito is, if hindi mo ma-solve yung equation, kasi, merong, sobra yung ano, no? So, you have to formulate two equations or three equations para ma-solve yung mga unknowns na yun, no? So, yun. So, anyway, sa mga problems natin sa example, so, baka maintindihan natin yung part na to. So B is you'll have to work on simultaneous equations, no? So hindi lang iisa. So could be example A plus B equals 5, and also A minus B equals 7. So meron kang two equation and two unknown. So masosolve mo yung unknowns na yun. So ganun yung ibig sabihin ng B na to. So the total number of equations of equilibrium for the entire frame and for the individual members will be larger than the number of the unknown forces and reactions. After you have found all the reactions and all internal forces, you can use the remaining equations to check the accuracy of your computations, no? So at the minimum is dapat equal yung equation available mo na equations, and compared doon sa equal yung available mo na equations dun sa number of unknowns, or dapat mas marami yung equations mo na available compared dun sa mga unknowns na hinahanap mo. So then after that, so it is important to check, no? So um, at the end of every problem, so it is important na maglagay kayo ng checking na solution, kasi there are cases na namali ka ng sign or namali ka ng arrangement sa equation mo. So pagdating mo sa dulo na is mali na pala yung naging sagot mo. So kaya important na i-check natin yung solution natin. So kagaya ng mga sample natin dun sa sa trusses. So nag-check tayo. Okay, so para ma-apply natin yung mga steps, so let us solve a sample problem. Okay, so sample problem 6.4. So in the frame shown, members ACE, so members ACE, so hindi siya straight member, so parang L siya, and BCD are connected by a pin at C, so ito, and by the link DE, so itong link na to, so DE. So for the loading shown, meron siyang load na 480 Newton at member BCD in line with point E or sa pin E. So determine the force in link DE and the components of the force exerted at C and members on member BCD. So yung hanapin natin yung force sa link DE and yung component ng forces present dito sa C or exerted on C. Okay, so first and foremost, una natin is yung free body diagram. So let me use this figure na lang for the free body diagram. So free body diagram, at A meron tayong hinge. So hinge is meron siyang X and Y na component, no? And sa B naman, meron tayong so this is a roller. So against this surface, so meaning yung perpendicular na perpendicular reaction natin is ganito siya. So this is B X. Ayan. And then sa A naman, so we will assume or by the loading, so since meron tayong applied load na 480 pababa, so probably yung maging reaction ng AY niya dito is pataas. And to counter BX, so yung AX natin is pakaliwa. But you can assume na lahat siya intention, no? So but para mas madali siya or para mas masanay kayo, so assume natin na AX. Ayan. Okay. So next is solve natin yung mga yung mga reaction. So, summation of forces y equals to 0. Upward force is positive. So, AY minus 480 Newton is equals to 0. Therefore, AY natin is equals to 480 Newton also. So, nasolve natin yung AY. And then, to find for the BX, so since all the X component ng mga forces is unknown, so mag-moment tayo at, say, at A. So, para present na lang na force is BX and yung 480 Newton natin. So, summation of moment at A is equals to 0, counterclockwise, positive. So, mag-moment ka sa A, perpendicular force ng BX is yung perpendicular distance ng BX to A is yung 160. And this creates a counterclockwise na rotation. Okay, so BX times 160 mm minus, so yung 480 naman is meron siyang clockwise na effect with respect to the moment at A, and yung perpendicular distance niya is yung 100 mm. So itong distance na to. Okay, so that is 480 Newton multiplied by 100 mm is equals to 0. Okay, so transpose natin yung equation, yung isang equation. So Bx is equals to positive 300 Newton. So meaning tama yung assumption. Ayan. Okay, so next is, so pwede natin ma-solve yung AF by summing all forces at x equals to 0. So Bx minus AX equals to 0. So meaning equal yung Bx and yung AX. So AX is equals to 300 Newton also. Yan. So nasolve natin yung mga reaction. So Bx is 300, AX is 300, and AY is 480 Newton. So before we dismiss, so next na gagawin is i-dismember natin yung frame to find the internal forces and apply the equilibrium equations to solve for the unknown. So, but before that, since meron tayong inclined member dito, so say this is alpha. So, isa-solve muna natin yung alpha natin. So, alpha so para mas maintindihan nyo, so say we have a triangle here where this is alpha and this is 80, ito, and yung baba niya is 150 mm. So how do you find alpha? So applying yung SOHCAHTOA. So SOHCAHTOA is sine theta is equals to opposite nung angle over the hypotenuse, and cosine naman is adjacent over hypotenuse, and tangent is opposite over hypotenuse. Okay, so in this case, meron tayong given na opposite na side with respect to alpha and yung adjacent side. So with respect to alpha, 80 is the opposite side and 150 is the adjacent side, and yung of course yung hypotenuse is yung longest side natin. So meaning gagamit tayo ng TOA. So tangent alpha is equals to opposite over hypotenuse, over the adjacent. And then, ilipat natin yung tangent sa kabila. So, magiging alpha is equals to the tangent inverse, negative 1, of 80 over 150. So, therefore, our alpha is equals to 28.07 degrees. Okay, so, nasolve na natin yung alpha. And then, i-dismember na natin yung frame. So we now dismember the frame. So since only two members are connected at C, so that is member ACE and BCD, where they are both multi-force member. So the components of the unknown forces acting on ACE and BCD are respectively equal and opposite, and are assumed directed as shown. So we assume the link DE is in tension and exerts an equal and opposite force at D and E direction. So ito yung magiging assumption ng mga forces natin. So at member C, since they're connected at pin, so there is a X component and Y component, and yung member D natin is a two-force member, and the assumption natin is in tension yung force niya. So at point D, at member BCD, tension yung FDE, and at E naman, at member AC, tension yung FDE. So, hindi, yung discussion natin kanina, may negative. So, ano lang yun for emphasis lang yun. But, sa actual na calculation ng problems, hindi ka maglalagay ng negative. So, as is lang siya, FDE, but opposite yung direction ng forces. Okay, so meron tayong tatlong members. Two-force member DE and multi-force member BCD and ACE. Okay, so for the member BCD, meron tayong 1, 2, 3, 4, 5 na forces and 3 unknown forces, that is CY, CX, and FD. So meaning, we can apply the equilibrium equations to solve for CY, CX, and FDE. Now we write summation of moment at C. So, para ma-solve muna natin yung DE, mag-moment tayo sa C para ma-eliminate mo ng CY, CX, and FD na lang yung unknown natin. So, sa FDE natin, meron siyang FDE, and meron siyang X and Y component also, since it is at a direction alpha. So, this is alpha here. This is alpha. So, this is FDE X and FDE Y. This is FDE. Okay, so summation of moment at C equals to 0. Counterclockwise, positive. So we'll start with the 480. So with respect sa C, meron tayong meron tayong clockwise na rotation. So yung effect ng 300 is a clockwise rotation. So negative 300 Newton times 60. So 60 yung perpendicular force niya, distance niya, yung D. And then minus yung 480 Newton times 100 minus, so yung gagamitin natin is yung FDE na, yung Y component ng FDE. So yung Y component niya is opposite to alpha. Say, i-transfer natin dito. So opposite siya sa alpha, meaning sign yung gagamitin natin. So FDE sine alpha multiplied by, that is 100 plus 150, so 250 equals 0. Okay, so the only unknown here is yung FDE, and alpha is 28.07 degrees. So, solve natin yung FDE natin. So, FDE is equals to negative 561 Newton. So, negative yung sign, meaning mali yung assumption natin. So, hindi pala siya tension. The, FD is in compression, no? 561 Newton compression. So from the steps kanina, pag nahanap mo na yung member, that kung opposite siya ng assumption, so i-change na natin yung direction niya. So FD is compression pala siya. Okay, so FD is in compression. Okay, so that is in compression. Ayan. Okay, so to solve for the CY and CX, we can now summation of forces at X is equals to 0. So 300 Newton. So 300 Newton plus CX plus, so since so since ito yung direction ng FDE natin, so magiging positive na yung X component niya. So X component ng FDE is FDE, which is 561 multiplied by cosine alpha, which is 28.07 degrees, equals 0. Okay, so CX is equals to, ilan yung CX? So that is negative 795 Newton. Okay, so that is 795 Newton. So meaning negative na naman. So meaning mali yung assumption natin. So force exerted at C is compression, not tension. Okay, so CX is equals to 705 Newton compression. Ayan. So CY naman, okay, so this is mali yung assumption natin. So compression, so this, ayan, yan yung CX natin, and then yung CX. Okay, so summation of forces at Y is equals to 0, upward, positive. So meron tayong CY minus 480 Newton minus yung Y component, which is 561, plus na pala, no? Plus 561 minus 561 sine alpha equals 0. So therefore, yung CY natin is positive. So yung CY is as is siya. So, ganito pala dapat. Tension siya but opposite direction. Ayan. Equals 216 Newton. So that is for the CY. Okay, so nasolve na natin yung mga hinahanap natin. Yung force at link DE and yung mga components of the force exerted at pin C. So that is the CX and CY. So, ito na yung maging direction ng CX and CY. Okay, so para ma-check natin, gagamitin natin yung member ACE, no? So, check. So, check natin, no? So, the computation are checked by considering the free body diagram ACE. So, magmo-moment tayo say at A. So, moment at A. Summation of moment at A equals to 0. So, dapat mag-0 din yung sagot natin, no? So, first is yung CX. CX. So, ngayon, CX natin is counterclockwise na siya. So, that is 795. Wait. Pumunta lang yung value. Yung ano muna, yung CX times 220 and then yung components ng FDE. So, yung components niya is for the Y component and the X component. Okay, so the X component niya is mag-create ng clockwise rotation. So, FDE cosine alpha and then yung Y component niya is mag-create ng clockwise rotation din. So, minus FDE sine alpha equals 0. So, no? So, ganyan siya. Hindi pala. Dito pala natin i-apply yung components niya. Dito. Ayan. So, lahat siya clockwise. So, meaning CX is 795 times 220 minus, wala parang distance to. So, this is times 220 plus 80. So, that is 300. And then, dito naman sa FDE sine alpha, meron tayong 100. Ayan. So, FDE is 561 times 300, cosine alpha cosine degrees times 300 minus 561 sine 28.07 degrees times 100 equals 0. So, ilang sagot dito? So, this also equals to 0. Okay, so, check. So, meaning, tama yung mga values ng na nahanap natin. Okay? So, yan. So, yan yung pag-analyze ng frame structure. Okay, so that's it for the analysis of structure, which is yung frames natin. So, these are the references. So, and yung main reference natin is ito. No? So, maraming example dito. So, you can also scan the book for more examples. Okay, so that ends our module 3.1. So, thank you for listening and have a good day.